Hi, my name is Jack Shirley and I'm currently studying furniture manufacturing, architectural woodworking in ATU Letterfrack. And this is my project based on the research title, Utilizing the 3D scanner to capture native forms and transform them into furniture. Going into this project, I was always fascinated by 3D scanners, so I was eager to learn more about them. The scanner I was using was the Shining 3D Einscan H1. This scanner is designed as a medical scanner, so it struggles with some textures, but is still a great scanner, as it is capable of scanning up to 0.5 millimeters of accuracy. I began my research by investigating the capabilities of the scanner. I found that it can't scan reflective objects, but works really well with objects with lots of texture. The scanner is designed to scan medium to large objects. I spent a lot of my time trying to manipulate the scanner to scan small objects. The smallest object I was able to scan was a standing lid. This was challenging and took a lot of time. The next thing I tried to do was to automate the 3D scanning process. I did this by building an automatic turntable. This way I was able to set up the scanner on a tripod and place the object on the turntable and scan it. This is by far the most efficient way to scan the object, but it only worked with medium to large objects.
I wanted to create a piece that encapsulates the natural beauty of Connemara. After some time, I came up with the idea of a rock hall table, so my next step was to find a rock. This took some time as I wanted to be an interesting shape, perfect texture, and be local to Letterfrack, as I intended to encapsulate the beauty of the area's natural forms. The rock I found is located on Renville Beach. Because of this, I decided to name my piece after Rinhuile, which is Renville in Irish. Because of the location of the rock, it was tricky to scan it, as the scanner needs to be plugged in to work. To get power on the beach, I had to borrow a generator. The next step was to go to the beach and scan the rock. I had to get the timing just right when scanning the rock, as where it is located on the beach, it gets covered in water when the tide comes in. I also had to make sure the skies were clear, as I had to scan it in the middle of winter. When it wasn't raining and the tide was out, there was a big rush to get down to the beach and get the rock scanned. This was a lengthy process and took nearly an hour between setup and scanning the rock. Thankfully, it was a great success and the scanner picked up every ounce of detail. I also got a lot of funny looks while scanning the rock on the beach at 11 o'clock in the morning on a Tuesday. Now that I had the rock scanned, the hard work began. I had to import the model into a software called Mesh Mixer to reduce the size of the file, as it was too big for any software to open. Once the size was reduced, I imported it into Fusion 360. Once in Fusion, I was able to slice the model into 36mm layers for machining. Then each layer was split up into multiple pieces to make it easier to machine. In total, there were 35 separate pieces that needed to be machined. Once I had all the pieces separated, it was time to program the files for the CNC. This was one of the longest processes throughout the whole project, as the geometry was so complex. This meant there was a lot of programming that needed to be done in Fusion to make sure there was no errors. Because of the complex geometry, each piece required its own unique setup and settings. This meant that each piece took over an hour each to program. Once all the programming was done, it was time to start the long process of machining out all the components. The pieces were small, but it still took a lot of time to machine. The machining was very repetitive. The steps were as follows. I first had to load up the file onto the CNC computer. Then I had to set up all the pods to hold the piece securely in the machine. The next step was to press the start button, being sure to keep an eye on the machine for any potential collisions. I also slowed down the feed rate on the changeover of bits to be sure there was no collisions there. Once the machining was done, it was time to take the piece out of the machine and start the whole process again. This needed to be repeated 35 times and in total took 21 hours and 38 minutes. The next step was to glue all the pieces together. I began by using the domino to glue the first layer together. Because of the complex shapes, I couldn't use clamps, so everything was held together with masking tape. Once the first layer was done, I then had a base for all the rest of my components to go on. From here on, I was able to glue on the following pieces as they came out of the machine. I did this using glue and screws. I was able to use screws as they were getting covered up by the next layer. Once I reached the top and was no longer able to use screws, I had to use masking tape to hold the pieces in position while the glue dried. It was important to be sure that every component lined up just right, so the rock looked exactly like the original. Once that was done, it was time to sculpt the piece. As it was using 3-axis CNC, it was unable to machine the undercuts, so I had to come back afterwards and do that by hand. I did this using a die grinder. This tool made quick work of the HDF. and was amazing for sculpting the rock. The die grinder left quite deep marks, so afterwards I had to use a Dremel with various attachments to sand all the way into all the nooks and crannies. Even with all the different attachments, this was still a difficult process, but in the end was well worth it. The next step was to CNC the top for the table. For the top, I have to have a piece of native timber that was full of character. After a lot of searching through all the timber storage, I found the perfect piece of native Irish elm with some stunning grain. As this was live edge, I had to bring it to the panel saw to square up the edges before I could plane and thickness it to size. Once the piece was to size, I loaded it onto the CNC, where it was cut to a perfect 20mm offset to match the silhouette of the top of the rock, with a 4mm groove for some LEDs to make the rock glow. The next step was to mount it to the rock. Once I was happy with the fit, I sanded it to 320 grit and oiled it with some Osmo oil. Once that was done, it was time to paint the rock. The paint was something that was going to either make or break this project, and I believe I made the right decision. I used 2 different types of paint. The undercoat was Rust-Oleum Desert Bisque, which is a sand textured paint. To get full coverage with this paint, I used 5 cans. Next, I topped it off with 1 coat of Rust-Oleum Stone Pebble. This just added more texture and depth to the paint. Lastly, it was all sealed with 1 coat of lacquer to prevent any of the stone texture from rubbing off. The last thing to do was to glue the rock to the tabletop and to wire up the LEDs. Once this was done, it was time to hang it and turn on all the lights. Once I turned it on for the first time, I was overcome with joy, as what was once an idea had now come to life exactly how I imagined it. The piece turned out great and does exactly what I wanted to do: encapsulate the beauty of Connemara.